All right, we're going to talk about simplifying rational expressions. So there's a couple things when you're simplifying that you want to be aware of. The first off is this isn't a fraction. So anytime you have a fraction, a rational number, a ratio there's going to be, usually there's a spot here in the denominator where we can't have a value. Okay, we don't want the denominator to equal 0. So we have some excluded points potentially. We want to make sure we find those. The second thing is you got to make sure you understand factoring, because factoring is going to be essential when you're solving these or simplifying these problems. So on our first example here, I have x minus 1 over 5x minus 5. Okay, so the first thing I want to do is factor both the top and bottom completely. Well, the top is factored. There's nothing I can do to x minus 1 to factor it more. So what I'm going to do is I'm going to factor the bottom. Notice both terms have a 5 in it, so I'm going to pull that 5 out. All right. Now I'm going to talk about excluded values. So I need to find the value that is going to make this a 0 in the denominator. And so what I'm going to do is I'm going to set this whole piece equal to 0, and that's going to be my excluded value. So I'm going to add 1, x equals 1. So that's my excluded value. X cannot equal 1. If x equals 1, I get a 0 here. Yes, it's a 0 over 0, but that still causes a problem. Now when we're simplifying, what we're going to do is we're going to cancel out things that are identical. So when you're canceling out identical items, if you have a plus or a minus, it has to be the whole piece of it. So I can't cancel out just the x. I have to cancel out the whole x minus 1. So they have to be identical. So since there's an x minus 1 on top and an x minus 1 on bottom, those cancel out, leaving me with 1/5. So this whole thing is going to reduce down to 1/5. Okay? We just can't plug in the value 1. So that's our restriction. In our second example, we have a little bit more robust problem here, because we have 3x minus 6 over x squared plus x minus 6. So now I have an opportunity. I can factor the top, I can factor the bottom. So I want to start by going ahead and factoring both pieces. On top, you're going to look for commonalities. 3x minus 6, okay, that tells me I can factor out a 3. So I'm going to factor out that 3, x minus 2. Okay. Now here on my bottom, I have to go back to factoring quadratics. So I need to find the factors of 6 that subtract to give me 1, positive 1. So remember that this is, my first term is positive, my last term is negative. They're two different terms, so it tells me subtraction. So the two factors of 6 that subtract to give me 1 are 3 and 2. So the 3 has to be positive because my middle number is positive. So x plus 3, x minus 2. And now I'm going to talk about my domain restrictions. Okay, I'm going to talk about the values x cannot be. Well, what value here is going to make this 0? What plus 3 gives me 0? Well, that's negative 3. And what minus 2 is going to give me 0? 2. If you can't do that in a mental math, please set these equal to 0 and solve for x. That's your domain restriction. Okay? Now I'm going to be looking at what is unique. What is the same in there? And I notice that there's an x minus 2 on top, x minus 2 on bottom. They cancel out, leaving me with 3 over x plus 3. And I still have these domain restrictions. And I still can't plug into, even though my simplified expression allows for it. Later on, we talk about that in different classes. Now, example 3 is unique in that I have a negative x squared. Well, a lot of times we don't like to work with negative x squareds. So what I usually do is I usually tell my classes to kind of get rid of that. Make that x squared a positive. Well, how do I make something that's a negative into a positive? Well, I'm going to multiply by a negative 1. So I'm really going to pull out that negative and switch the sign around up on top. Okay? And so what that does is that allows me now to kind of still use those same pieces. Yes, I could factor this on top. It's not a problem. I could understand that 2 minus x is the negation of x minus 2. Okay. Now I'm going to factor this. Okay, so the top factors into x plus 2, x minus 2. Right, so I'm looking at the factors of 4. That subtract to give me 0. Here, I just find the greatest common factor. So 7x and 14, I'm going to factor out a 7. X minus 2. Now that I have it factored, I'm going to talk about that domain restriction. I don't have to worry about my numerator. I only have to worry about my denominator. So here, x cannot equal, well, what makes this 0? It's a positive 2. So these pieces cancel out because they're the same. So I have negative times x plus 2 all over 7. I could bring this negative in, make it negative x minus 2 over 7. They're all the same. It doesn't really matter. You could leave it like this. Okay? So that's simplifying rational expressions. Make sure you understand domain restrictions, what makes that denominator 0, and you're going to have to factor these.